Welcome to Math Challenge 319, and here we have an irregular quadrilateral with only one of the angles 90 degrees. A quadrilateral, all the sides are unequal, all the sides are given, all the sides are unequal, and only one of the angles is 90 degree marked. We have to find the area of the quadrilateral, and this can be done easily just in less than 10 seconds. So this is a math challenge. These types of questions are useful for Olympiad test papers, railway staff selection, banking recruitment, public service exam, and also all math aptitude tests and competitive exams. So let us see how to find the area of this quadrilateral. And draw the diagonal as shown. We have shown the diagonal by the dotted line. So when you draw the dotted line, we actually divide the quadrilateral into two triangles. One is right-angled triangle and the other is a scalene triangle. So one right-angled triangle and one scalene triangle, we can divide the quadrilateral into two parts by drawing the diagonal as shown by the dotted line. So we will concentrate on the triangles one by one. So first, let us concentrate on the right angle triangle. We have shaded it for your convenience. So we are concentrating on the right angle triangle. Two of the sides are 72 and 30. And we have to find the length of the dotted line, that is the hypotenuse. The dotted line is the hypotenuse, and we know that two of the sides to be 72 and 30. So using Pythagoras theorem, we can calculate the length of the hypotenuse or the diagonal as 78. See the calculation, 72 square plus 30 square, and then we take the square root, that is 78, that is the length of the diagonal or the length of the dotted line. We found out the length of the diagonal as 78. Now let us concentrate on the unshaded triangle, which is a scalene triangle. And now we know all the three sides of the scalene triangle. 84 and 90, these two sides were given. And the third side, the dotted line, we calculated as 78. So we have a scalene triangle where the sides are 84, 90, and 78. And now we have to calculate the area of this scalene triangle. Now, since we know all the sides of this triangle, the unshaded scalene triangle, so we can use the Heron's formula, that is square root of s into s minus a into s minus b into s minus c. So we'll be using Heron's formula to find the area of the unshaded white scalene triangle. Heron's formula, first we find semi-perimeter, that is 84, 78 and 90 added, divide by 2, that is 126. Then s into s minus a into s minus b into s minus c, which is giving you 126 into 48 into 42 into 36. We have factorized it. And on taking the square root, we are getting the area of the scalene triangle as 3024. Meanwhile, on the left side, we have also taken the area of the right angle triangle as half base into height, that is half into 30 into 72, that is 1080. So the area of the quadrilateral will be equal to the area of the right angle triangle plus the area of the scalene triangle, that is 1080 plus 3024, and the total area we are getting as 4104 square units. So by drawing the diagonal and finding separately the areas for the right angle triangle, we were using half base into height, and for the scalene triangle, we were using the Heron's formula, and by adding the two areas, we got the total area of the quadrilateral as 4104 square units. That was the easy sum just by drawing the diagonal and finding the length of the diagonal by using Pythagoras theorem. Everything is made so easy and so simple, and the area of the quadrilateral is readily calculated. Thank you. We'll come back with more such videos. Till then, thank you and goodbye.